This is an example of read-only memory in crabs. It uses binary, where a 1 is a crab and a 0 is the absence of a crab, but it has one major flaw, and that is that it is read-only. It can't be written to by crabs themselves. The only way to change it is to remove a crab yourself and to add one somewhere else. That's the only way it can be modified. So in this video, we're going to try and fix that and make some bits that can be written to. So for this, I'm going to use a real example. This is the 4-bit computer that I've been working on. You guys who are following on would already know about it. By the way, I have updated the game again. I'm trying to make it a lot faster, and so I've got a timer up here to see how fast it's actually running at. It's currently capped at 60, but I'll be fixing that shortly. So in this computer, this here is the read-only memory that I've got for the current line number. So obviously this cannot be changed. I cannot modify this at all because when crabs go in there, it just deletes it. But for this to really be a computer, I want the line number to change, either incrementing each line or by jumping to other lines. So to do that, we're going to have to find a way to get crabs into here and destroy these or place crabs into there. So I've just taken a read-only bit of memory and put it here, and I've got a sinker here to make sure we are keeping it the same. So what we're going to do is just keep building onto this until it's able to be written to by crabs. And I'll explain the idea in a moment, but first of all, thanks to the person who commented on my last video, these are now called crab tunnels, as in this structure here that sends crabs into these blocks, and the crabs inside are called tunnel crabs, so thank you very much. And that frees up the word phase, so now phase is what you call where a crab is in relation to another crab. So these are out of phase, whereas these are in phase. Okay, so back to this. So the idea is we need to send crabs into here. So first of all, we need a way to rotate crabs up and into this. So we're going to leave these purple blocks here for a little while. Now, what we could do is just send crabs straight in, and it's fine to do that, but it toggles the bit. It doesn't set the bit to a value you want. And so if you do actually want the value to be set to exactly 1, for example, then sending a crab in there just doesn't do it. It's going to toggle it. If it is already 1, then it becomes 0. So assuming these actually line up, which they probably won't, if they did, they would both be annihilated, and this would be 0. So it's essentially toggling it. So the idea of how to fix that is we need a way to stop crabs from going in under a certain condition. So what we're going to do is we're going to send the first crab through, and this is going to guarantee that this bit is now off. So if we guarantee that it's a 0, but we still want it to be a 0, then it's problem solved. But if we want it to be a 1, then we first guarantee that it's a 0 and then set it to 1. So hopefully that makes sense, but I'll explain what we actually have to do. So first of all, we need to get this crab stream to go around here. So we need to twist it around. We need a way to read it from back here. So what we'll do is send this crab through here, clone it upwards, and then rotate it around. So that's basically what we're doing. So that gives us 2 crab streams. We can read it from the back now, so we can rotate it down. So that's pretty good. We can still read it from the front, and we can now read it from the back. But now we need to make sure that if a crab goes through here, it actually lines up. So I'm going to set that up now, and I'll just bring this back to here. I will get a sinker ready, and I'll just figure out what phase it has to be and get back to you. Okay, so this is the phase it has to be. So I'm just going to make it so when this guy gets to the right side, then I'll place a crab, and then this should line up with that. So there we go. When this is on, it sends a stream out the back. So this actually guarantees that this bit is on after sending the crab through, because if this wasn't here, the crab would go through and it would now be on. So in both cases, the bit is on at the end. Now this does work, it's okay, but I want it to be a different way. I want it to be guaranteed that it's 0 so that I don't have to negate the value that I send into it. So what we'll do is a neat little trick where we're going to have a cloner up here that is always on. So for example, it might be here, I might move it in a second, but it will send crabs out. They will go down, and now this crab stream will stop this crab stream when it's on, and when this is off, this will come down. And this crab cloner here is the one that is going to stop incoming crabs. Now it turns out this is actually a good spot, so I'm going to leave it there. Now this is the phase it has to be, and I know it's not in sync with everything else, but it doesn't have to be. So now when this is on, when the bit is on, then this stream is off. And when this is off, then the stream is on. So now I need to make sure that these line up. Okay, so I've just now made it so they line up. So what happens is when you send a crab through, you are now guaranteed that this is off. So if I was to clear this out and just let a crab go through, then you'll see that it actually does go in, but it may not be in the right phase. It's actually too off. I was just thinking a better way to do this, like an improvement from last time, would be to have two different phased crabs. So like this, it would be the phase for the crab that guarantees that this is off. And then another crab might come through with a different phase that actually sets the value. What we'll do is I'll have another sinker down here and I will work out what phase that has to be. And so after this guarantees that it's off, as it has just done, then I'll work out what phase this one has to be and I'll just send another one through. And this one is going to actually go in, and I'll get rid of this because I don't want to use that anymore. It's going to go in and set the value, and it should be in phase with this. Okay, so I got that surprisingly quickly. That was second try. So you can see that this crab goes through and it completely avoids these, which is actually okay. Goes up and you can see it's in sync. So that writes the bit. Now, if that did not go through, then obviously the value would still be 0. And now this guy is the one that guarantees that it's 0. So this is actually a way improved design from last time. My last one is down here. It does basically the same thing, except this one is just way better. And this here is actually not even shown on this side, but it's a lot more complicated. So if I got rid of that, that's the size difference. So much better, and hopefully I can use that in the new 4-bit computer. So just to finish off, I am going to make sure that this gets cleaned up. So I'll put a crab bin, and it looks like it has to be like that because I can't really raise it any higher. But that should be okay, so there's not too much waste coming out of it. I'll put a link to this in the description. It'll just be a map with this on it in the middle. So you can play around with it if you want to. Maybe you can make your own RAM before I do. But yeah, you can see it's quite a bit more complicated than just read-only memory, but that's expected. But maybe in the future I can make one even simpler, or maybe even you can make it. Also, if you've made maps of your own, I would love to see them, so feel free to send them to me. Basically, just send me a comment if you have something to show me, and I'll find a way for you to send it to me. And yeah, maybe if you could make something out of this, that would be pretty awesome. Next video will either be talking about this bad boy, or it'll be a 7-segment display, so we'll have to wait and see. See you in the next one.